One of these circle theorems is called the cyclic quadrilateral theorem. And a cyclic quadrilateral just means that it's a quadrilateral where each of the vertices or corners lies on the edge of a circle or the circumference. So each of the four corners fits on the edge of the circle, and it's a quadrilateral, which is a four-sided shape. So when we have a cyclic quadrilateral or a four-sided shape penned into the circle, the opposite sides are adding up to 180. So y and w will add together to make 180 degrees. And similarly, x and z will be adding together to make 180 degrees. And the same thing would happen on the second one, so it doesn't have to be over the full circle, it can just be in half a circle or anywhere at all, as long as the four corners are on the edge of the circle. So here we'd have the same thing, both P and R would add together to make 180, and Q and S would add together to make 180. So we already know that the total angles in a quadrilateral add up to make 360 degrees. And so what we're doing here is we're able to say that when it's in a circle, we can also use the fact that the opposite angles add up to 180 each, and therefore 360 in total. So in these two examples, we're trying to find x and y, and then r, p, and q. So for the first one, we know that the opposite angles are going to add together to make 180. So therefore, 180 minus 110. So 180 minus the 110 from the other side is going to give me my final answer, which is going to be 70. And similarly, for x, we know that it's 180 minus 85. So 180 minus 85, and that gives me 95 degrees for x. So I can now find angle x and angle y. On the second example, I can use the same idea. So 180 minus 70 is going to give me q, because they are the opposite sides of the quadrilateral. Even though this one looks a little bit different, this is still the opposite of this one here, and then these two are the opposite of each other as well. And then to find P and R, we're going to have to use the 135 that I was given. So both P and 135 are on a straight line. So together they add up to make 180. At the moment we know that this part is 135, and therefore 180 minus that 135 is going to give me P, which is 45 degrees. Now that I know that P is 45, I can do 180 minus that and find that R is 135 degrees. So in these questions, we're again using this same idea with the cyclic quadrilateral. So each time you're looking to see where that four-sided shape is that's drawn inside the circle. So as soon as you see that, you know that you're using the cyclic quadrilateral. On some of these later questions, we can see we still have that four-sided shape, even though we have some other things happening as well. So for the first one, we have 115 minus 180 is going to give me the x, and then 180 minus the 102 is going to give me the y, because we know that the opposites add up to 180. The second one would be exactly the same. These two add up to 180, And these two add up to 180. So we just do 180 minus the 83 and 180 minus the 108. To find z, we would then use y. We know that together they form a straight line. So 180 minus y would then give me z. And it would be very similar for question C and then again for question D. But question D uses the vertically opposite angle. And we know that W and 72 are the same. We can then use the angles in a straight line for W and U. For the next question, you've got the cyclic quadrilateral, but we can't easily see where to start because we don't have any of the corner pieces. But we can find Z straight away. Z is going to be 360, the full circle, minus 164. So that's going to give me 196 degrees. And then we can find X. And we can see here that we've also got a arrow shape. So we have the arrow theorem that we've already looked at. And the arrow theorem tells us that this angle here is double this angle here. So X is just 164 divided by 2 and is therefore 82 degrees. Now that we know that X is 82, we can use that to find the opposite angle in the pink quadrilateral. So 180 minus the 82 is going to give me 98, and that's the answer to that question. Question F is very similar. So again, we can find U by using the 360, it's the angles around a point. And then from that, we can find V using the arrow theorem that we see here. And then we can work back to find W and back again to find X.